Today I'll be dealing with the last topic in our fuzzy inference systems, fuzzy defuzzification. So I hope you are all clear with the entire working of the fuzzy inference system, how to represent the discretized sets from a continuous set using fuzzification methods, and then you apply the operators for fuzzy operators and an or in the antecedent, and then you use an implication through which you get the implied fuzzy function for your output, and then aggregation of all the rules, and finally for the aggregated value you're going to do some defuzzification to get back the crisp output, which can be like a severity of a disease. The output variable's actual crisp value is what we need, or we are going to get with defuzzification function. Okay, so I think we already saw this. So this is about fuzzification. We know the inference rules, the operators that we use in the inference rule, and or operator. If it's going to be the and, it's going to take the minimum, or means it's going to take the maximum, so on. And then we go for the implication, and whatever we get through the implication, we apply it for the output variable. And then through the aggregation process, we get the aggregated value here in the defuzzification part. So how do we get the actual crisp value belonging to the aggregated value, or crisp value, or the domain value for that problem of application is what is determined by the defuzzification function. And I told you there are several defuzzification functions. Even in the MATLAB toolbox, you would have noticed that there are so many things like MAX and Centroid method, SOM, LOM, so many short forms you would have seen. So there are so many fuzzy methods, defuzzification methods. So I'll deal with a couple of them for you right now. And the reference book has all the formula and also an example explained very clearly. And I will be explaining one example for you now. The first thing is max membership method. So whatever is the maximum membership among all the aggregated classes. So whenever I speak here, it's about all these three things for three classes over here. Class 1, class 2, and class 3. And max membership means between these three, what is the maximum membership. So all that I deal over here will be with respect to, this will be the first method, first one, second one, and third one, right? So whatever methods I get together, that will be the mean of three means, or three deals with this first one, second one, and the third one. So we take three shapes that are given there, and whatever I have there is what. So the centroid method is integrating over all the area and taking the central point of that. So I'll show you how this integration formula works using a typical example, right? So weighted average method, you can give weights for each of the shapes that are over there, and from that you can take an average for that. That's the weighted average method. And the mean max membership is mean of maximum membership. So out of all the n sets, what is the maximum membership? For example, if you take the example over here, so out of these three, this is the maximum membership, and I take the mean of the max. So this is what is called mean of the max membership. So several approaches are there. Let me consider two functions here, right? So now assume these two to be something like the three I showed over here. I had three over here, right? 1, 2, and 3. Aggregating these three, I've got something over here. Likewise, you think of this as 1 and 2, right? So this starts over here, and this is slightly skewed diagram because of my poor photography. I took it from a book. This should actually be 2 and 3, right? So I've drawn this diagram over here again. So this is the two membership functions that I showed you over there. So this is between 3 and 4. So roughly you can guess what will be the functions of these lines, right? What is the equation of y-axis? X is equal to 0, yeah. So this is x is equal to 0, this is y is equal to 0, and this is equal to 1, and so on and so forth. So using the 2-point form, you can get the equations of these lines here. So this is going to be, what is this point here? 1 comma 0, and so this point is, the membership value is 0.7. So what will this point be? 1 comma 0.7, right? Likewise, this will be 2 comma 0.7, right? And likewise, you can compute these points here, And once you get all these coordinates, this is 0, comma 0, you can compute the equation of these lines. Yes, there's no difficulty in this, right? Of course, you have packages doing all these things. There's no difficulty here. So you can compute the equation of these lines. The same things, I'll put it over there and explain to you the remaining formulas. So this is going to be, and this point is, what will be the equation of this line? Y is equal to 2.7, sorry, 0.7. Likewise, the equation of this line will be y is equal to 1, right? And I am actually interested in this region. This line doesn't matter to me. So this will be my final shape that I get down. Right? So you know now how I got the shape. There are two different implication functions. The aggregation of those two implication functions, I've got the aggregated defuzzified, aggregated shape, for which I'm going to do different defuzzification methods. Okay, so so this is going to be 0, y is equal to 0.7, and the different points here. This point is 2, 0.7. This is 3, 1. This is 4, 3 to 4. Okay, sorry, I did a small mistake. This is supposed to be, okay, 2 to 3, 3 to 4, and then 4 to 6. Okay, then the equation of this line would be 0.5x plus 3. So my first line is y is equal to 0.35x, and my next line equation A12 will be y is equal to 0.7x, right? And this point over here, the intersection of these two is going to be 2.7, 0.7. The intersection of two lines you can understand, right? So this is A11, this first line, 0.35, and this is 0.7x. And the next general thing that we had there was it isn't sloping down, so it is minus 0.5, right? Okay. How did I get this 2.7? So we have y is equal to 0.7, and then y is equal to x minus 2. So at that point, x minus 2 is equal to 0.7, so we get 2.7. Simple geometric operations, right? Okay. So now my centroid method, the formula is given there. I knew I'll write it here just further. the notion is to integrate the values across each and every partition. So I divide this into different partition and I integrate the area onto the curve, right? So what is the first limit? It is between 0 to 2. So it is between 0 to 2 and I integrate 0.35 x. So x and x is squared together and I get. And then my next area is 2 to 2.7, this point over here. This whole thing constitutes the numerator. So don't confuse. This whole thing now with the entire area. So this is with respect to x. Now this is for the complete area. It's going to be so what I've written here is this very same formula that I've put up on the presentation. I've written this formula there, right? So integrating with x and then the whole area below. Okay. What is integration of x dx? Anyone? X square by 2. Good. So you can solve that. So x square dx is going to be x cube by 3 and minus 2x will be 2 minus 2 into x square by 2 and 2 and 2 gets cancelled, and then you apply the upper limit and lower limit and subtract it, all these things, right? And finally, you can verify answer. Your numerator will be right. So you can verify this as a homework. And there's one more example in your textbook that has 3 functions. So that'll be a little larger than this. That's also clearly solved there. You can take it as a homework and look into it. The same formula, there were different examples. Here I've used 2 fuzzy set, aggregation of 2 fuzzy sets. There they would have used 3 fuzzy sets, right? So that's also a classic example. You can take that. And this is the center of gravity method. And can you relate this formula to somewhere? Can you relate this formula somewhere you studied? Engineering mechanics, center of gravity. Okay, here it is called centroid method or center of gravity method. You take your first year UG engineering mechanics book and see how you'll calculate the center of gravity of a solid area. This will be the approach. So next one we'll go for is the weighted average. So, by the way, what is this? X star? What is this X star? What is this X star? What is this X star? Sir, class, sir. I'll join by 12. Yes, sir, sure, sir. Yes, Centroid. But what is it relevant to? crisp value. Yeah. So if your heart disease severity level is between 0 to 100 or 80 to 500, some domain value, you would map these output functions like less severe, prone, obese, or something like that, right? The classes you'll be mapping within the continuous value range. So when you have these classes, then if you want the crisp value, you can go to this thing, right? And whatever the crisp value lies, wherever it lies, you can take it as your class. If you want it in the crisp value format as your output, you can use this defuzzified value, or you can directly go for any one of the defuzzified classes. Okay, so that is what XStar is about. So here, computing XStar. So summation of the fuzzy sets for the values of X, we get the membership value and the appropriate weight that we want to apply. So here, the membership value for the first fuzzy set is going to be, the summation is for I is equal to 1 to n, where n is the number of fuzzy sets. Here it is 2, n is 2, right? You have considering 2 sets. So these are the respective membership values of those classes, and these are some weights that I want to assume to those classes. So these weights can be arbitrary weights, or even the another weighing function is there where you assume the mean of those classes. Here also something like that can be done, right? So this value comes to something about, so this is weighted average. So the next method is mean max method. So here we are going to take the mean of the maximum class, right? So what is the maximum class here? The second one, right? That has the maximum membership value. Mean of the maximum class to be the crisp value. So what is the mean? X star is going to be a plus b by 2, where a and b are going to be these two values. Sorry, yeah. So a plus b by 2 for each of these classes. So it is going to be 2.5, because the mean of these classes, mean of the maximum values, right? So this is the maximum value of this class, and this is the maximum value of this class, mean of the maximum values. So it is 2.5 plus 3.5 by 2, which is 3. And in some weighted average approaches, they use this 2.5 and 3.5 as weights, apart from the membership value that we give here. Instead of this 2 and 4, they use 2.5 and 3.5. So that's also another version of weighted average method, weights based on the height of the membership functions, the degree of membership they have is used for this. Another approach is center of sums. You would have seen this. Mean value, and you will be having one more center of sums, which is, understand this now clearly. Now this this 4 is going to be the base, which is 4 units. Is this color visible? Yeah, base is 4 units, and this is maximum membership area. So this is actually, see here. So this is with respect to the first class. So the base was initially 4 units, if you remember, right? So the base was for 4 units and the distance of the maximum membership unit is 1. Got it? Center of the entire thing. That's why it's called the center of sums. Got it? So hope you understood how I got this 4 and 1. Likewise for the next class, plus a. Why is this 4 again? This function extends from 2 to 6. 2 to 6, and the area is again between 3 to 4. Got it? The values of these two values. This is the base value and the max area of the max mean area. Why it is 4 and why it is 1. Okay. So this is the numerator divided by without those things. This is the only new thing that is coming here. Understand this clearly. This thing is due to base and the top. Likewise, should be clear over here. Initial diagram is not here. Okay, that's fine. So the last things are to first of maxima. So what is the maximum membership function? The second function, right? So the first of maxima will be the first point in the maximum fuzzy set. So first of maxima will be 3. First of maxima. Likewise, the last of maxima. So these are several approaches. So based on how you want the severity to be interpreted in your domain, you can use the appropriate membership function. Okay. So these are several approaches for what? Several approaches for, yeah, defuzzification. Centroid, weighted average, mean max, and some other formula are not here. Okay, so before we wind up, a small quick example. So this is one of the experiments that your seniors did. So given a face emotion system, recognition system, you have several variables. Variables can be length of the iris or the distance between the nose and the distance between the lips or any of the variables. And these variables are specified using as inputs, right? And these are the various parameters which you can set. And method is going to be min, or method is going to be max, implication is going to be minimum, and aggregation is going to be the maximum of all the things, and defuzzification is going to be a centroid method. And for each and every variable, I use a different modeling. right? I hope it's just to give you a recap of the entire fuzzy inference system. So each of the input variables has different modeling functions, and the modeling is shown over here, whatever it is. Several input variables. So depends upon how much of knowledge you have about the domain, and then you have several rules for each of the. If action unit 1 is MF5 and she is not new. AU is action unit. Action unit means they have different units on the face, like 1, 2, 3, 4, 5, 6. You would have seen that pictures now having dots and things like that. So those are called action units. So value of action units is mapped to different fuzzification functions, and these serve as rules. And these rules, then based on these rules, you have the membership rule overview, and from these rules you give the inputs of the actual observations that you get from the data set. You generate the rules, and these rules are going to give you particular outputs, and those outputs are mapped together. So if you have some particular rules that are fitting for a situation, then if AU6 is MF2, this is MF2, and AU7 is MF2, MF2, and so on. And then the output is MF1. It is mapped over here to MF1. So likewise, this mapping, this is the implication process, this is the aggregation process, and finally you get the defuzzified one. And the defuzzified one, you can see that you have chosen the centroid method. And so for this kind of a shape, we are taking the centroid principle. Okay. So that's it about fuzzy inference system. With this, I'm done about fuzzy inference system and all the methods pertaining to it. That's all for today.